Okay.
Okay. Hello, everyone. Thank you for coming to this session. We're going to do something different, not normal for the format of most of the conference. We decided what we do is chop up this session into, I think, how many we have here? 7 talks, around 10 minutes each, for various people who are contributing to the Spring Data and Spring Integration projects, to kind of show you things that are in the works, just kicking around, so that you can see what's going on, and also give us some feedback if you like something, let us know. And we're going to kick this off today, focusing on sort of web-related technologies. We'll have David talking about Groovy DSL, Scott talking about things you saw in the keynote relating to using integration patterns inside JavaScript in the browser, WebSockets, and then a little more detail again on something you saw in the keynote yesterday, this REST shell and the Spring Data exporters. Then Mark is going to talk about a new model that we're playing with for having a higher level of composability and reuse around Spring integration and batch. Gary and Jared will talk about adapters for Salesforce and Splunk. So I'll hand it over to David now, and I'll have this timer here, which will go off and I think bark at you when your 10 minutes are up. And that's
okay. I have 10?
a soft
okay.
warning. All right. Take it away, Dave.
Okay. So we have a Groovy DSL for Spring integration. Still early days, but it builds into the Spring Snapshot repository. So it's available. It's here's the GitHub link at github.com under Spring Source Spring Integration DSL Groovy. So it's kind of a sister project to the Spring Integration Scala, and taken some of the semantic that was built into the Scala language, Scala DSL, and ported to Groovy, but Groovy is quite different than Scala, and the audience is different. So there are some similarities and there are some differences. Uses a Groovy builder or the Groovy factory builder to build the markup language. Any questions? I'm done. No, I'll go a little. Factory builder support is the Groovy class that comes in the Groovy libraries that allows you to build things like this. So here's a simple example. So you can create an instance of an integration builder, and then you there's a couple of top-level methods. One is a message flow. If you're familiar with Spring integration, message flow I think of as kind of a chain on steroids. So you don't really need to provide any channel information between the components. They will just be executed in order. Like the Scala DSL, we have verbs like transform, filter, route, and handle is equivalent to a service activator. And the endpoint logic is backed by closures, which makes it really interesting. Without closures, you could look at it as a kind of a more succinct XML that uses Groovy markup, but we actually can execute closures, and then you can do things like send and receive on a flow. And so in this case, we have a transformer. It's going to take a payload to uppercase. We're going to have a filter if the uppercase version of that is equal to hello in caps, and then we're going to handle it, basically output the payload, return the payload. If otherwise if it's not equal to caps hello, we're not going to do that. So you can see the test will say if you pass in hello or anything with those letters in combination of uppercase and lowercase, you'll get a result. Otherwise, you get null. So that's a pretty simple example. These message flows can be nested. You can pass also. You can define input and output channels like you would do in Spring integration, not always required. If there's no channels defined, it uses some conventions like the name of the component .input channel and creates these things. And you can also um, get a handle on something called the integration context. So aside from a message flow. So in this case, we actually define two flows within a Spring integration context, and so we can call either one. Flows can also be nested or can be invoked as subflows. Let's see if we have an example of this. Okay, here's an example of a subflow where I'm saying exec subflow from a main flow. You can also nest them inline using the builder. Some interesting things with routers. There's a lot of flexibility using these closures. So here's an example of the convention. So I'm saying I have a router, and I'm saying if the message is hello, then route it to upper dot input channel, otherwise route it to lower dot input channel. Well, we don't have those channels explicitly defined, but by convention, the input channel for this handler named upper is upper dot input channel, and the handler for lower is lower dot input channel. You can do a recipient list router just by passing a list inside the closure. And in this case, we can test this, and each one increments a counter, and we assert that the count is 2 at the end. So there's more stuff. This is the README on the GitHub, and I don't have time to go through it all, but it's out there. Like I said, early days in snapshot mode, but it basically works. I want to. So also, there's something I should mention is with the closures, and not unlike Spring integration proper, you have an argument, a single argument to the closure, which could either be the message or the payload, or it could be a collection of messages or a collection of objects. So I'm doing some type of coercion where I'm looking at if the closure parameter is declared as a message, then you can get the message and you can get the headers and the payload. If it's just a def or it's not defined what it is, you just it'll strip out the message and just give you the payload, and works with collections and arrays and things like that by default. Some other nice things it does, we're looking at, for example, the HTTP adapter. You have an HTTP outbound adapter, and it has a URL. That URL is a string. It just gets passed through as a regular URL, static URL, but you can also pass it a closure, and Scala does this too, similar. You can say the URL is defined as a closure. In that case, there's some function that's going to execute to figure out, that's going to return a string that should be the endpoint that you want to connect to dynamically. So that's likewise aggregators, splitters. You have release strategies and correlation strategies that can be backed by closures. Do have to rush through this. I want to take a look at the cafe demo example that comes with this and just show you the configuration. So this project is a work in progress. There's a core module, and then like mirroring Spring integration, if you want HTTP or JMS or AMQP, there's separate modules for that, and potentially there could be a lot of these. Suffice it to say that you don't need to implement everything, because I also have a component that can use Groovy markup just to pass in the equivalent XML into Spring, and so you can if it's not there, you can integrate very easily with the XML equivalent. So what happened? Okay. So let's look at what Cafe looks like here. So I've do with Spring integration, and I have this Spring XML tag, which it can basically, you can create any bean or do anything you could do in Spring. There's some namespace support and so forth. So the barista is implemented in Java here still, and I have a cafe, a gateway for the cafe, and because I don't have gateway support in the language yet, so I can do it this way. So it's sort of the XML equivalent of how you would do a Spring Integration Gateway. So we're splitting the orders coming in to the drinks channel. We route the drinks if the payload's iced, cold or hot. A queue channel for cold drinks and a queue channel for hot drinks. And then the aggregator has a closure here. We say we get a bunch of drinks, and when we aggregate all these messages, create a delivery with those drinks. And we correlate by get order number, and then handle the output, which basically prints the output to standard out. So, and we have Polar. So this example actually works if you download and run it. I think the Gradle, I just added to the Gradle script, so you say Gradle run cafe, and it'll run, and it looks just like the original cafe demo. So that's about all I have. Thank you.
So while we're getting the computer switched over, just a question. Who here feels comfortable writing JavaScript? So a few hands. Okay. Of the hands that are raised, who likes JavaScript? A few fewer hands. And a couple new hands actually came up. Okay. So let me... There we go, okay. Okay. What's that?
Still, I didn't see it.
1280 by 720.
It doesn't go. This is.
I have this set up
Yeah.
to mirror.
Oh, change it mirror. Yeah.
Are you sure?
Yes. You can go mine. Second one. You can bring it this. Yeah. Display. Yes, sir. Thank you.
Okay, let me see if I can...
Yep.
That's still good?
Yep.
Okay, sorry about that. So what I want to show you is a black browser with a circle. It moves around. And I'm done, thank you. So as Adrian mentioned last night in the keynote, we created a library called Clicks that can capture UI events inside the browser, actually any type of event inside the browser. Anything from a mouse movement to a click to keyboard to press, window resize events, just anything that a browser in the standard DOM model or other eventing model supports. So what we've been able to do with that is actually build up, a lot of events that come across. So then we kind of naturally hit, the next question, okay, we've got a ton of events. What do we do with them? And there are a few of us on the team who came up with slightly different solutions in terms of stream processing. Being one of a Spring guy, was familiar with Spring integration and, took inspiration from that and created what at the moment, at least we're calling Integration.js. So if we come over here, in the client, essentially, just to go through it really quickly, so there's an integration object, and that itself is a message bus. And inside of that message bus, we can create a couple pub sub channels, so to server and from server. Then between those two channels, we can create a WebSocket bridge where we provide a sock.js path and basically bind the output to from server and the input channel as to server. So it's pretty basic. Well, what that allows us to do is if instead of just having one browser with one circle that moves around, we can have caching. There we go. We can have two browser windows with circles that move around, and depending on which browser window I'm in, it automatically gets reflected over to the other browser. And what you'll notice is this is running locally. There's almost no lag, there's almost no latency, and it's just ridiculously fast. It's using WebSockets. Messages are transferring over across I'd say the wire, but it's all local almost immediately. But what we can also do is I have an instance of the same app running on Cloud Foundry. So it's circles-2gx.cloudfoundry.com. I tried to do this demo in my talk the other day, and it didn't work out so well. But it's not working now. It was working a minute ago. Let me restart the app. Did I mention this is alpha? All right, so now I actually have two circles. So if other people log into the app, all right, proof it's working. So if you start to follow your own circle, what you'll notice is that it actually kind of, it's a little slow to log to follow. Essentially what's happening is because this traffic is going from your laptop across the hotel Wi-Fi network, which is inevitably slow, all the way up to Cloud Foundry on the other side of the country, and then coming all the way back. And that's a lot of circles. So essentially, inevitably you can see the actual latency visually. But the other thing you'll notice is that it actually kind of stutters a little bit. And that's because instead of actually using WebSockets up to Cloud Foundry doesn't actually support the native WebSockets implementation. So it's falling back to HTTP long polling. So essentially these events are getting batched up into actually individual HTTP requests. So instead of receiving one message at a time in real time, we're actually getting chunks of messages at a time. So that's why the circles tend to jump a little bit. And if I actually jump over to the server-side code, this will look familiar to what Adrian showed you last night in terms of just creating a very basic web server. The one thing that's a little bit different is that we're pulling in that same integration library. This is inside of Node.js on the server. And what we can see is that when I was running locally, I just had a broadcast pub/sub channel that when a web service connection occurred, created a node stream bridge. So node streams have a very common API for emitting events. So sock.js happens to implement that API. So that's what the bridge I used. So input and output are the same channel. Except for when I was running on Cloud Foundry, I was actually running with multiple instances. So typically if you're connecting to one instance, if you're only broadcasting within that instance, only clients connected to that same instance will actually see the same events. But in order to distribute those events across, basically using a Redis bridge on Cloud Foundry to broadcast all those messages using pub/sub across the three instances, and then broadcasting it again back to each of the clients connected to each of those instances. And with that, I will apologize that I have to run off to another session, but I'll pause for questions if there are any. Code is not public at the moment. If you look at the Keynote repos that Adrian had last night, you will find a snapshot of clicks and integration in those repos. We're kind of looking towards trying to get that more publicly available in the future, particularly if there's interest. All right, thank you.
That was off, wasn't it? It seemed the screen didn't show all of it. Here it's okay, but it's
Just,
choppy.
yeah, it's only,
Maybe you need to drag it.
Drag it.
Say
actually, we, oh. Oh, you know what? I bet it's because, let's see. I bet this screen, that the native one, yeah, it doesn't have. Let's try the. I think you can see enough.
Yeah.
Because
All
you
right.
just, we only want to show them the
All right,
code.
okay.
Right. Thanks.
Okay, you can turn it on.
Okay. So.
All right. Who came to the WebSocket talk early this morning? All right, seems to be a good crowd. So since I'm a committer on the Spring integration team, and WebSocket support is certainly high on our list of things to implement. And if you followed our introduction this morning, it's that things are still quite a bit in flux, particularly on the JVM side. So we follow a few different strategies experimentally. And one example I would like to show you is, just move this around here. Yeah, explodes here almost. Is an implementation of SockJS using Spring integration running, using the TCP support we have in Spring integration. So basically, not using any pre-libraries, but literally using as an example, implementing the SockJS, the WebSocket protocol, using the TCP adapters within Spring integration. So there's no external library being used. And as you can see here, we use the... Oh, yeah. We have the TCP connection factory, and the way, and that basically is listening on port 1880, and the magic of parsing the SockJS protocol, that's being done in the WS serializer. When we get into the okay, here we go. And here we basically implement the kind of like experimentally the WebSocket protocol. Pretty much as we discussed this morning, we're doing having this the pongs, all the good stuff. Somewhere we have also the masking. You basically illustrating as an example of how you can actually use Spring integration using the TCP support, or also if you wanted to use the UDP support, basically to create high throughput, your own wire protocols easily using Spring integration. So this actually has an interesting side effect as well. If you wanted to talk about WebSocket support, is that we would actually, when you develop Spring integration application, you always kind of like to bring data messages basically as early under the umbrella of Spring integration as possible. So you basically have full control of the messages, exception handling, routing, etc. Within Spring integration. So this is actually an interesting alternative or at least an interesting approach of implementing socket support. Oh.
I'll get the other one. Bang. I think what Gunnar's means there is that the TCP adapters are pluggable in terms of the wire protocol. So if you have some custom wire protocol that you need to talk to a mainframe or some other system, it's easy to plug in a custom serializer, deserializer using this technique. And all we did was basically write a serializer, deserializer that understands the WebSocket protocol, plug that into the adapter, and then we can use either using NIO or not using NIO. You also see, if you go back to the Java class, Gunnar, at the bottom, just scroll all the way to the bottom. No, that's the class. Scroll down to the bottom. So this method here is actually doing the WebSocket handshake. So if we go back to the Spring integration flow, you can see that we have a router in there. So depending on, like during initialization, we route it to a service activator that invokes that handshake. Once the handshake's done, then we pass the message just to a little service activator that's simply sending an incrementing counter back to the browser.
So basically, let me just run that example.
Did you debug it? you run it in debug mode. Yeah,
Okay.
just kill it. Just run it with the green arrow.
Okay. It's booting up. Refresh. WebSocket has been opened. Let me just see where do you get the...
So just click on the send WebSocket there.
You do this
It says start
start.
there. That's basically sending a message to the service activator to start incrementing this counter.
And we should see some activity as well. So the messages are being sent out. The counter goes up. We can stop. It's being
It doesn't
stopped.
actually close. That's not closing the WebSocket. It's just leaving it open. We're no longer sending data to it, and then you can start it again, and it just resumes.
So that kind of like opens also a few strategies for us to how we move forward eventually implementing WebSocket support or etc. on within Spring integration. So of course we could use something like Vertex, basically use that as kind of like an adapter itself to provide us WebSocket, SockJS capabilities within Spring integration. We can use, still working on atmosphere-based adapters that will allow you to basically provide socket support. So because the notion is that in many regards having the WebSocket support is a messaging concern. So something similar like Vertex, for example, which has that event bus feature where you can send any kind of message basically to a moniker you define, and people subscribe to particular names you're sending messages to on the web browser client, on connected WebSocket non-browser clients. I mean, people can connect to your system based on standalone applications, etc., connecting to your system. So it really is not necessarily a web concern, but potentially something you have in your middle tier, basically broadcasting those messages out. Having those various adapters within Spring integration is kind of interesting. And this is just another option that we have to actually bring the WebSocket concerns even closer under the umbrella of Spring integration. So just want to show you that, and you probably see more activity in our extension repository over the next weeks and months in regards to support for asynchronous HTTP using WebSockets, SockJS, etc. So Thank you very much.
And just in the interest of transparency, the reason for the Chinese fire drill here to get the Linux box was that it currently doesn't work on Mac. So we had a last-minute panic there. So, but.
Next, we'll have John Brisbane, who will speak about the data exporters in Spring Data JPA, and then the REST support on top of that, but also diving a little bit into the REST shell that you saw in the keynote, which seems to be a little bit of a small surprise hit at this event. You only spent a day writing it, though.
2. Okay, as Mark said, I'm John Brisbane. I'm going to be giving the Spring Data REST talk tomorrow afternoon after lunch, so if you feel like sticking around, appreciate it. Let me try and get this thing on here. I just want to show you real quick the finished project that I'm actually going to be building out, and I'm going to start from much less than this, but I just kind of want to give you an idea of what we're working with on the back end, because to show the REST shell, you kind of need to know what's going on the server side. So I gave a little bit of a preview yesterday if you were in that session, and we've just got some basic JPA repository managed entities here. So we've got the entity itself, and then we've got a repository to manage it, and we're doing a little bit of extra magic here by mixing in some paging that we get automatically with that. And then we've got we're using a Servlet 3 web initializer here to export this and basically just take our basic project and turn it into a web project. So there's no web.xml. And the only thing really to notice in this is that this application config class is at the root, and that contains all your JPA entity references, your data source, the repository references, anything that's like application level config. It all needs to be set up ahead of time so that the exporter can find it all, because we try and reduce the overhead by not looking for things and we just at startup. So the only real addition that we've added here, we just created a regular dispatcher servlet, and we're passing in our special config here. I'll show that real quick. And there's a standard configuration class that comes with Spring Data REST that imports all of the necessary components to do the routing and whatnot. And this is a little event listener that will listen to application events. So that's our basic setup, and of course there's other classes in here that that I can talk about in more detail, and the validation. There's Spring validation. There's JSR 303 validation and whatnot. So quite a bit of stuff in here to go over, but really kind of just wanted to give you an idea of that's what's going on behind the scenes, and I think my server is already running here. Let me check real quick. Yeah, let's start it up. So then the REST shell that you saw earlier there. Is based on Spring Shell, which the Spring Shell project extracts the important parts from the root shell and gives you an easy way to write command line applications. And you just have to write a few classes and annotate them correctly with the CLI command annotation and give it your options and whatnot, and it will manage completion for you, history and whatnot. So we get a lot of stuff for free. We get tab completion on all of our options. Since it is the Spring Shell, we get the bang, so we can actually do shell out to system commands directly from the shell. And so the important thing about the REST shell is that it takes away the drudgery of developing HTTP-based hate OAS applications. Now, you don't have to use the Spring Hate OAS library. It's a helper. It's there, and we use it in Spring Data REST. But you don't have to use it. The reason that it's helpful to kind of coincide with how Spring Hate OAS is presenting resources is that, especially with the REST shell, we get to interrogate those resources, those links that we've been talking about. And every time that in Ben's presentation earlier, and then last night we were talking about resources being linked together, and this concept of links. And so basically you get a couple of different commands to aid in that. One of them is discover, and I've got actually an Nginx server running here. I'm proxying at this address, and if I typed it correctly. Okay. What it did is a get, and it interrogated this links property, and it pulled all these out and presented it in a nice little table. So you can either do list or discover. Discover just does a couple operations. It sets this base URI, which is just like setting your working directory. So we're setting our working URI to this base URI, and then everything else after that's going to be relative. And it caches the URLs here based on the rel value. So the rels are actually important. When you're doing HTML and whatnot, you just don't really pay attention. It's always style sheet or whatever, and you don't really pay attention to the rel value. But in the Hate OAS world, the relationship type is important to that particular link. And I'll talk about it more tomorrow with the Spring Data REST and how we use the rel. But for the purposes of the shell, all you need to know is that you can substitute the rel value for the actual URL. So this coincides actually with the relative URL here. Ads is also a relative URL, so they match. So you can't tell there's a difference, but here there is actually a difference. So if we do ads search, then we're going to refer to that particular URL. Now list, you see, just lists the resources. It doesn't actually change the working path that you're at the URL. Discover and list are how you kind of interact with that, and then we've got this idea of following links, and of course we also have help. So we get some documentation on what the different options mean, and the README should have. I just updated it a little while earlier here with most of the options and whatnot. So hopefully there's a little more help there on that, but you can follow a link. And so the idea of following these links is that you start out at this root URL, the first one that we entered here, and then you follow or discover other resources, and that's important to the Hate OAS principle, is that you don't know these URLs necessarily ahead of time, and that does become important when you're scripting things and you're looking at the location header of a resource you just created, and it's giving you back a UUID or something. I mean, otherwise you'd have to parse the URL of the header, and so by following links from one to the next and interrogating the links property of the resources that you're getting back, you can, in the JavaScript client in the browser, or REST template, or however you're doing this, that you can actually kind of keep track of where you're going. One of the nice things about the pageable repository is that it includes this default paging information. And if we had more than 50 elements here, you would see in the links section in here you would see a next link referring to the next page of results, and then if you would move on to there, you'd see a previous link if it's so it's contextualized if there's no previous link on the first page and whatnot. So the links that you're actually presented in the Hate OAS world are important. They're contextually important. And you'll see that in this JSON representation, which is these 6 entities, and the resource that we're pulling up here is the actual list of entities, and we've got this links property, and that's where we were pulling the URLs out. And then we've got, based on Spring Hate OAS, we're using a content property, and so rather than value or something else like that, we're representing the entities inlined in the response in this content, and then each entity has its own set of links referring to itself, which is important. When you get down into a hierarchy and you're looking at related entities, you want to be able to refer back to a particular entity at its root URL, because you don't, if you're not going to, if you have a person entity and you have profiles related to that entity, you're not going to manage a profile, like delete it and create them through the person. As a REST resource, you're going to provide a URL where you can create profiles, and you can associate them with people, with person entities. And so in the REST shell, we're allowing you to work with that by using these rel values and looking at the links property. But that's an important consideration when you're developing these on your own. A couple other things here that we have in the REST shell to kind of help you out developing the timeout value, which will become important if you've got a long-running process, or you're working with a cloud provider and you want to be able to do some quick turnaround. You can set a real low timeout value so that you can have things explode very quickly rather than waiting around all day for them. The history command I showed you, there's a couple history things there. You can every time you set your base URI with the base URI property or a command, or you do a follow or a discover or any of those other discovery commands that actually alter where your base URL is, it's going to put an entry in the history. So if you start working in the shell for any length of time and you start following these things down in the hierarchy, it's pretty handy to be able to just history go back to the a particular earlier base URI, and you can go up to, which takes you up in the hierarchy. It's just a lot of commands for manipulating these URLs and moving yourself around in your REST resources to make it feel like you're on a in a terminal in a directory structure or something like that. All of the HTTP commands, get, post, put, delete, and just the basic ones that you need to do your CRUD are supported here in the REST shell, and they have a couple different ways that you can use that. Like if you're doing a get, like we've got, let's follow ads here, and we've got this search. Okay, and we happen to have a finder method on our repository here that's exported, and then this is the data that we're getting here. We can actually add parameters to that if it was a, this particular finder method doesn't require any parameters, but if we needed to, we could do a get and pass parameters. Now, one of the things that Ben was mentioning earlier, and this is just the way that the Spring Shell works and the way it parses the stuff out, is when you're creating JSON, you're not creating real JSON in the shell inline whenever you're providing it as part of the params, or on the data switch if you're doing a post. You can't put a space here either. I mean, they're just little limitations on the way that the particular, the parsing is done on this. So it looks kind of weird when you're typing it, but as you can see, it adds the query parameters on there. And if you're using parameters, we're representing them as JSON here rather than question mark name equals, and that's just an easy way to specify them. If you're doing a post, however, let's go up. We could do a post here and create a new one. Of course, we've got some validation on this particular entity, so we can't just create one. but we can load from a file. So we could say, we want to create an add a JSON file, or we could say, if we have a directory full of JSON files, we could say load all of the JSON files in this directory, and for each file it finds, it will do a post to that URL. Delete's pretty straightforward. There's not really a lot of controversy around a delete. It will just whack the resource that you specify. There's really no other options. All of these, though, you'll notice have the output, so that when you do a get on this, you can actually specify output.txt, pipes it out to your output. And if we wanted to load this up in our text editor, we could say output.txt, and we would get the output loaded in there. So we can load from files and we can output to files, and this is really handy if you're not just doing this interactively, but you're actually creating a script. And the Spring Shell, one of the standard things that it can do is take a command file argument, and you can pipe in your commands that you've scripted for doing testing and actually batch loading and things like that. So, is that are we done? Okay. So we'll go into some more detail on that tomorrow on the back end part of that of the Spring Data REST. So, Mark.
You have for John? Can you post a form is the question.
Ben and I were talking about that earlier, and actually wanting to do some multi-part uploads and things like that. Right now, the REST shell is pretty much designed around JSON, getting and posting of JSON data. In fact, it does it does some validation under the covers and assumes that you're working with JSON. So that's just a limitation of the REST shell at the moment. But certainly, kind of as we're starting, since this is only like, I don't know, 2 weeks old or something like that. I mean, we literally just came up with this, in the course of working with Spring Data REST, that now we're starting to see, hey, there's lots of ways that we could be using this, and multi-part uploads and attachments and things like that are, something that would be really, really cool to be able to handle. But we're going to have to add an actual command to do that. So. What? Yeah, you can. The headers. I didn't show the header thing that Adrian showed last night, where you can set the accept header. The same thing you can do with if none match and all that for doing. It just takes any HTTP header. So basic authentication, the whole 9 yards.
All right. Next, we have the man who needs no introduction. He's going to show us some things he's been working on to make Spring integration more modular in terms of configuration flows and also incorporating batch elements. I don't think this is on, but maybe yours is?
Yes, it sounds like mine is on, which is good. I'm kind of recovering. Don't have much of a voice, which was one of the reasons we switched to this lightning talk format. I'm pretty sure in the end, though, it's a lot more interesting than if you had to listen to me for the whole 90 minutes. So I hope you agree. I guess I'll follow on Scott Andrews' lead and say, how many people here are comfortable writing XML? And how many people like writing XML? Okay, good. Dave Sire, of course. A hand as high as he can get it. No, seriously, one of the things that I think you've probably seen a lot, I was embarrassed after Jürgen's long exposition on the merits of annotations. To be the first example of XML in the keynote was a Spring integration configuration file. But hopefully, as you've seen from what David Turansky was showing, and if you were in the Scala talk this morning and saw Oleg present the Scala DSL, we're doing a lot of work to have alternatives to XML. We also are planning in the 3.0 timeframe to basically build a meta model that all of the different DSLs can rely upon instead of having to go through the same process as the XML bean definition parsers. And once we have that, we plan to build a Java Builder API so that you could have pure Java configuration. One of the things that is a little bit different about Spring integration in defense is that the configuration is usually defining components like a channel adapter, a router, a filter that don't correspond directly to code that already exists. You're actually declaring these components in the configuration. So it kind of by nature has to be externalized. Okay, I'm running out of time. So one of the other alternatives that we're exploring with the prototype that I'm going to show you today is to actually hide the XML by providing a higher level way to build modular flows. One of the strange things I've learned in the last 5 years in the integration space is that one of the ways you compare yourself, your framework with other frameworks, is how concise is your echo example. So we've had a few run-ins on that. So I'm going to start with that right there. What I have on the screen right now is actually an echo example, literally using a pipes and filters format. So what I can do is type into the console here, say echo, and I get a response. So what I'm doing here actually under the covers is I'm wiring in a channel adapter that is the inbound system in reading console inbound adapter, and I'm just piping it directly to an outbound adapter. This is a Spring integration application. There's a channel sitting between those two channel adapters, and that's all that's really happening. If I want to replace this with standard error, I can, and then I can say echo this in red. And now it's in red. All right, so I'm actually swapping out the adapter here, and I didn't have to go in and edit any XML. If I want to add another step in between, let's say I want to make it uppercase. I have a flow that's a Spring integration. It's just a single transformer defined, and I named that exclaim, and I have it in a flows directory, and therefore it's available. And now I can say echo this in caps, and it echoes that in caps. So what's actually happening here is it's just reading in this configuration, and it's assembling an application for modules that exist within this directory structure here. So you can see I have inbound adapters, and that's where standard in lives. If I wanted to make it really concise, I could have just called it i.xml, and then I could add ipipe o, I had o.xml, right? But I figured I'd leave some room to improve in the future. We have the outbound adapters here. We have the flow. Here's where exclaim lives. And again, it is a Spring integration application, but it's very simple. Transformer, and it has an expression. And the expression's parameterized. Now, you saw that it made it uppercase. What's actually happening is that as I'm running this, I also determine what environment. So in my arguments in the runner, I'm saying it's demo, so it's actually reading that in from demo.properties. And here we have the expression, should be somewhere in here. Yeah, flow, exclaim, expression. So I can modify that here, or I can override it at the level of the configuration here, saying expression. And instead of exclamation, I'll just repeat the payload twice, say, for instance. Now I can say echo, echo, echo. So that's the way that this works. Obviously, it's using Spring. It's using Spring profiles. It's using the environments. It's using the property placeholder, a custom property source implementation, actually, that first, it's a level thing. So the first level it checks is if it's in the config itself. Then it falls back to the environment, and then it falls back to the default environment from there. And obviously, you can have in the flow, you could have, just using standard syntax, you could have your default here, specify that default value. Okay, so one of the things I wanted to do is then kind of move beyond this echo example, because we're supposed to be talking about big data. The first thing I'll do, though, is just to kind of show you another adapter. Let's say HTTP. Okay, with HTTP, I now have an inbound HTTP adapter, and I can, let me increase the size of this. Maybe not quite that much. Let's see if okay, so here I have, I sent test, and you see test was printed out here. I can make multiple paths if I want, multiple inbound endpoints. So I can do path is black goes to standard out, and path red goes to standard air. Okay, and now watch the console. It's first into black, test is printed out from standard out. Red, test is printed out through standard air. So it's actually just registering these, it's registering streams basically with a really simple prototype of a stream server. There's another aspect here, which is the channel. When you see the pipes, it's creating channels. Behind this, we actually have an abstraction. So right now, it's using the default, which is an in-memory direct channel. But if I change this property in demo.properties, let's say I want to use rabbit for those backing channels, I can change this to rabbit. And it's probably going to bomb on me here because I don't have rabbit running, but that will be, let's just go back to echo real quick. Keep it simple. This will be your way to know that I'm actually using rabbit, because I think it will fail. Yes, failed to connect to rabbit. I go here and I start up my rabbit server. And now what it's going to do is every time I send the standard in, it's actually going over a rabbit channel that it creates and registers a rabbit queue. In this case, it does support pub sub and point to point, so I can actually clarify that in the individual channels if I name them explicitly. So I can use, in that case, a fan out exchange or a direct exchange with a queue bound to it. Okay, so I rerun this now that rabbit's running. Say foo, and I get foo, and it went over the rabbit channel. I can probably show you real quick. How much time do I have? I might go over just a little bit. Okay. Okay, so yeah, you can see in here, rabbit standard in to standard out was created as a queue, just using these default names for those implicit channels. Okay, so I'm just going to switch that back for now. And one of the other things here is that we want to start bringing Spring Integration and Spring Batch more closely together. I think if you've been following Spring Integration, you know we've been bringing Spring Integration and Spring Data much more closely together. If you were in the What's New talk today for 2.2, you saw the Mongo support and the Redis support that Oleg presented. We're starting to do more with, we have support for Gemfire. We have support for Spring for Hadoop. We have an HDFS writer that I'm going to show you in just a moment. So we're really trying to build these things out so that it feels like it's just an ecosystem. And our ultimate goal is that you don't think, I'm going to use Spring Integration here, Spring Batch here, Spring, but you just start thinking of it as, I'm using the Spring framework and it provides all these various libraries, so I use the ones that I need. Okay. So next, Batch. Sorry, I forgot where I was. Another thing that is supported by Spring is task scheduling, but I don't want to use any XML. I don't want to use any annotations. I just want to say, I think I have a hello world example, and I can just say hello world and then give it a cron expression. So let's just run this every 10 seconds. All right. So that is a cron expression, and what it's actually running is I have a jobs directory, just like I had inbound and outbound adapters and I had flows. Down here I have a hello world configuration, and in this case it's really simple. It's just literally a runnable. All right, so I can schedule that, and that's what I'm going to do when I run this here. So we should see it print out hello world every 10 seconds. And the time. Okay, so I can run a runnable. I can run a batch job, and I've added a batch job here that is actually also connected to a message channel. So this is something that's in the Spring Batch admin, Spring Batch integration library. You can run, you can use a item writer that's actually writing to a channel. So this is something we see people need this functionality quite a bit. They want to be able to read a file. They want to be able to use batches facilities for line item reading, tokenizing, splitting, putting things into a format like reading from a comma-separated list format, and then sending that as a message. So they're not really using batch more than for that entry point. And that's what I'm doing in here. And so it's a pretty straightforward batch job, and I'm writing out to an item writer. You can see I've defined this as job, and the item writer is writing to a channel called output, and that's just the naming convention that we're using for now. So I can run this, and it just prints out email addresses. But you can imagine, so let's change this to mailer. You can imagine that these then go to a Spring Integration splitter, and then they go to a Spring Integration outbound email adapter. But what you're going to see right now is they just get printed out to the console. And they don't. Okay, sorry, dispatcher. Oh, I forgot an important step there, which is the channel. Yeah. So I wanted to print them out. So it was sending to a channel, and there were no subscribers on the channel. And that's the #1 most common exception message that you'll see from Spring Integration. Dispatcher has no subscribers. Okay, so every 10 seconds this should print out the email. And now what I want to do is actually get to, in my last minute here, a real big data case to an extent. You can imagine with the HTTP endpoint that I had before, that could be your collection for, say, clickstream analysis data or something. But what I'm going to do now is basically what you saw in Mark Pollack's demo the other night, reading in Twitter Garden Hose. So I'll start by just Twitter Garden Hose to standard out. And we're going to start seeing tweets. And disclaimer, this is what you see here is beyond my control. It's a really depressing thing. I've spent a lot of time watching tweets go by lately, and especially at like 2 o'clock in the afternoon when most people are at work, you see some really sad stuff. Okay, so that's running just directly to standard out. What I want to do is add a tweet counter, and what terminology here is, call this a tap. So we have a stream, and we're going to tap into that stream and look at the data in real time. So what I'm doing here is I'm actually writing out counts of hashtags and mentions and ticker symbols, the different entities that can exist in a tweet. I'm writing those to Redis. So I add the tweet counter. I go into Redis. Okay, let's see. And here I'm just looking at the top 10 tweets. Oh, nice. See, what do you say? It's a non-stop source of entertainment. Anyways, I didn't even know. Here I am on the stage. Okay, last step, and then I will leave. So now what I'm doing is I'm actually piping it to HDFS instead of standard out. And I think that was temporary. I just today made this work so that I didn't have to restart it. There's a few little bumps. But let's just look at the Hadoop tweets directory. So you can see, I think these are files that were already in there. There's one from, is that today? 17th? Yeah. The rest were from last week. So I have some data that was already stored in HDFS and some that's being added. But basically, now I'm counting in Redis, and I'm also writing to HDFS. And then we have a MapReduce job called tag count, which is using Spring for Hadoop. And so just like you saw, I can run a runnable, I can run a batch job, I can also run a MapReduce job that's dropped into the jobs directory. Tag count is here. I'm not going to go into the detail, but it is a It's using Spring for Hadoop, and it's reading in. So here's the actual job. It's counting hashtags from that tweets directory. It's writing them out to this file. And then we have a little web app that's doing a tag cloud, and I'm just going to show you that. And that will be it. Okay, so there's the Hadoop data going by in our tag cloud. And this is the Redis data that's been going through the counter. So you can see there's not as much in Redis right now. There's more in Hadoop. We also have we have another runnable, just simple runnable that's called flush all that calls the Redis, using Redis template. It calls flush all command through the connection object, and we can schedule that to run, and we flush Redis every 10 minutes or so that we never get too much data in the real-time tag cloud. Okay, and I think that's it. I'll pass on to Gary Russell, who's going to talk a little bit about Salesforce adapters that we started working on for Spring integration. Thanks. No, I don't want to take questions. Actually, if you don't mind, we'll go ahead to the end and then take questions for the last few sessions, I think. No. I will, though. Just keep an eye out. Like I said, this is really just a prototype, but this is the direction that we're going. So parts of this you'll start seeing in the Spring Integration 3.0 roadmap. I don't know if you were in any of the other sessions, but Spring Integration 2.2 is we should be releasing RC2 within a day or two, and then GA within a couple weeks, and then our focus is on 3.0, and you're going to start seeing some of these things there.
Hello, can you hear me? Okay. This was some work I did earlier in the year to use Spring integration to interface with Salesforce. For those of you maybe not aware, the Salesforce got a pretty extensive REST API and makes it really easy to integrate. So we built this demo. We have two demos. One is mail to Salesforce, and the other one's Salesforce to mail. So if we add a new lead, for example, we it goes. We have an inbound channel adapter, inbound Salesforce channel adapter that gets that lead, does some transformation on it, and then sends it out as an email using a mail outbound adapter. And then the other one is we can actually send an email to an account. We have a mail listening adapter, and that then sends the lead up to Salesforce. So just quickly, we create a new lead in Salesforce, and back in my STS world, we should see. Did I just create? Oh, I did Bill Jones. So it already happened, and it's actually sending it to my VMware mail. So let me bring that down here, and sure enough, right now it's just sending the raw JSON as the text of the email. So and I'll show you the Spring integration configuration for that. Similarly, we can create a new mail or send an email to this account. It's kind of funky. It's just configured. You know, it's just looking for a list of properties. So I just type in the last name, whatever, and the company. These are two required fields in Salesforce. Send this email. And the other app it's just gone. Let me shut this down. And if I go back over to Salesforce, let me switch back to leads. You can see here now that lead that I just sent an email. I sent an email to that email account. A mail inbound adapter picked up the email, did the transformation, and sent it over REST. The Spring integration flows, one of the things I really wanted to point out here is really how easy it is to extend Spring integration, which is effectively what we did. Let's take a look at the mail to SFDC first. All I did was create a new message handler, and most convenient way to do that is to extend the abstract message handler. I don't have any namespace support yet for this, but you can see how easy it is to use a custom handler. You just wrap it in a consumer endpoint factory bean. So this effectively is the same as having a in-SFDC outbound channel adapter. What the parser does is create this consumer endpoint factory bean. So we have a mail inbound idle channel adapter. That's listening for new emails in that mailbox. A little bit of transformation. It's, as I say, I'm converting that list of properties into a properties object, and then sending it to this outbound channel adapter. Now, the outbound channel adapter is reliant on. There's a project that is up on GitHub called Spring Social Salesforce. This isn't a Spring Source project. It was done by an individual contributor, and it was a reasonable starting point. It has a Salesforce template, for doing. When we started looking at it, it only did read-only things, so you could get leads and such. But so I actually patched it to allow for updates, and you can see he merged it into master. So we can create objects, and that's how. So I now receive the mail and call this the Salesforce template to update the to create the lead. The adapter itself, or the message handler itself, is using Comet under the covers. And I'm sorry, that's on the sending side. And I'm sorry, yes, that's just using this. This Salesforce template to send the message. So it's basically his project, and then we just have this simple message handler as a wrapper around that Salesforce template. On the inbound side, it's a similar picture. Except we have this SFDC message-driven endpoint. Now this one I coded from scratch. It doesn't use his template because it's actually using long polling and Comet to. So that's why that's why we got the event so quickly. And as you can see, it's just the message-driven endpoint is wired directly into a mail. We do some header enrichment to put the mail subject from and to on, and then just send it to a mail outbound channel adapter. The message-driven endpoint itself, as I said, it's just using. It's using it's using Comet. It's using a Bayo client from the Comet library. And it's pretty straightforward. When a message shows up, we create a Spring integration message, and with the topic in the topic. So pretty simple stuff, and who knows where it'll go. But it was a sort of prototype work that we did earlier in the year. Any questions?
Okay. Hi, next we have Jared Lee, who's here all the way from China, who developed the Splunk adapter that you saw briefly used in the keynote.
Okay. My name is Jared. I work on the Spring Integration Splunk project. Spring Integration Pollack is an extension for Spring Integration, and it's now in the Spring Integration extension. So you can find the source code here. So basically, Spring Integration Splunk adapter is a component to push data into Splunk or pull data from Splunk. So I have two demos. The first demo is get the data from Twitter and then push the data into Splunk. Here is the configuration for the Splunk outbound adapter. This is the Twitter inbound channel adapter. We try to use this adapter to get the tweets from Twitter, and then we can do some transformer. For example, I'm only interested in the tweets from Jared. This is me. And then we push the data into Splunk. So this is the Splunk output channel adapter. So in this component, the most important one is Splunk server reference. Here we reference where is the Splunk server. So this is the data that we reference. We define where is the Splunk server and some other information. So I can run this demo. So I can write a tweet. And then I switch back to Splunk and try to search the data I just tweets. Here you can see this is the tweets I just pushed into Splunk. And the second demo is we can also pull the data from Splunk and then push the data to other applications. For example, we can pull the data from Splunk into database. This is the second demo. For example, we use a Splunk inbound channel adapter to pull the data. For example, I'm only interested in some data here, and then we do some transforming, and then insert the data into database. So this is the inbound channel adapter example. I forgot to insert the data into the database, so there is no records. So basically, this is the example to get the data from Splunk and then insert the data into other database. So that's all. Okay.